Hey there, and thanks for stopping by the channel. My name is Matt Marrash. I'm a photographer and videographer based here in Columbus, Ohio, and even though I've only been a photographer for 17 years, I've been making and storing digital media for well over 30 years. Way back in the 90s, it was storing my very first HTML files that I created, documents, and even a few video games across these bad boys right here, these 3.5-inch floppy disks. For the really young kids out there, a 3.5-inch floppy is what the save icon is based off of. It's a real thing. It's kind of silly. Fast forward to the 2000s, those file sizes grew and 1.44 megabytes per disk wasn't cutting it, so we shifted up to CDs and DVDs. These are some DVD-Rs with a whopping 4 gigabytes of storage. That's quite a bit more. In the mid-2000s, when I finally picked up a camera, I already had about a terabyte's worth of songs, movies, video games, and just every other document I had in my digital life up to that point. The cloud was just becoming a very, very new thing, and it wasn't where I was keeping my stuff. I eventually started piling up these bad boys, some 3.5-inch spinning hard drives, also known as HDDs. But the pile of these kept growing, and my data needs as I made more photos and videos only grew. What was I supposed to do from there? Well, in college, I was friends with a lot of tech majors, IT security guys that were building computers out of spare parts, and they were always playing around with these mysterious computer-like things called servers. I was a little bit too scared to even ask what those things were, but every time I would talk to them about all the photos and videos I was starting to take, they just shook their head and said, "You need a NAS." Back in 2005, I had no idea what a NAS was, but every time I filled up a new drive, it was becoming clear I probably needed one. When the world came screeching to a halt back in 2020, I knew it was finally the time to dive into the world of network-attached storage. Before we dive into my first NAS build, I want to make sure we're all on the same page about digital storage basics. A network-attached storage, or a NAS, is any device accessible on our network, wireless or hardwired, but not necessarily connected to the internet. In fact, it's usually better if it's not connected to the internet. This gives us an extra layer of redundancy just in case something happens on our main computer. Hard drives go bad, motherboards, power supplies. We'll get into some of the bad things that can happen later. And once we have something like a network-attached storage device, we can start employing things like our 3-2-1 data retention policy. 3-2-1 is one of the most basic setups for keeping extra copies of your data and being a little more resilient than just YOLOing it. 3-2-1 simply means 3 copies on 2 separate types of media, with one of those pieces of media being located off-site. So, for example, I have this copy of a YouTube video that is on my desktop, and while it's doing okay on there now, something might happen. So just to hedge against that, I'm going to go ahead and drag and drop it over to an external drive, my little external SSD right here. So I've already got 2 copies of my data on one spinning hard disk that's in the computer and an SSD that is external. So I already have 2, 1, 0. We need to get something off-site. If I were to simply just take this off-site, that could work. And why do we want something off-site? Well, sadly, accidents do happen. Things get hit by lightning, fires start, floods happen. I've experienced a flood. They're not fun. And it's always good to have that extra copy. One thing that now exists is the cloud, so you could pay for a subscription service to somebody else's computer and drop that in the cloud, but if we're talking really large files, the cloud gets incredibly expensive and you run out of space much quicker than you think. So having something off-site, maybe at a friend's house, over at a relative's house, or even in a rental or co-located facility that's a little more advanced, is another way to do it. So while there's other more complex data retention policies beyond 3-2-1, for most of us out there, if you're already making a backup copy or you have a series of external hard drives, you're doing better than the vast majority of people that have a copy somewhere that they probably can't locate really, really quickly. But 3-2-1 makes it even better. You have access to it. Now, of course, there is cloud storage. Cloud storage has become incredibly popular, and it's become a little bit less expensive over the years. But essentially, a cloud storage account is just you renting out somebody else's computer or data center somewhere else. Cloud storage depends entirely on your access to the internet, so the speed of your internet connection is going to limit how much data and how quickly you can access that data through the cloud. In most emergency situations involving the cloud, we often want to get that data back as quickly as possible, where now with a cloud service, you can be hit with what are called egress fees. Basically, you want your stuff back? Well, you got to pay us a little extra so we can prioritize your data. So backing up our data is important and all, and we probably need some of that data off-site, but why a NAS? Well, because components die. This camera, this computer over here, the CPU, the hard drive, the power supply, things go bad, and they typically don't go bad when you want them to. Let's take a look at some of the most common data storage devices and their average lifespan. I've got here a 3.5-inch spinning hard drive from HGST. This bad boy is rated for about 3 to 5 years of continuous spinning use. The longer it's spinning, the higher the likelihood that I'm going to receive an error, or sectors of these little platters can go bad. Once enough sectors are corrupted, I'm not going to be able to read or write any data from them, and whatever's on there is kaput. I can't pull it off without incurring a ton of cost, paying someone to basically rebuild it. On these SSDs, which you may have a stack of at home, these guys are a little bit faster, and they also have a maximum number of reads and writes that they can do before, well, the data's gone. Also, in any of these devices, if the charge cuts out, so we unplug it rapidly from a power source or from the computer we're reading and writing it from, we can lose data that way too. If you're a photographer watching this, you know you probably shouldn't have all your eggs in one of these bad boys. This SD card or a micro SD card or a flash drive, these can go bad just at the worst times. And keeping everything on there is not only slow and unproductive, it's a little bit dangerous for your data. So the addition of a NAS isn't a guarantee that you're not going to lose your data. It's more or less spreading out the risk across more drives. Let's take a look at some very common NAS layouts. For starters, we have the simple 2-bay NAS. This has 2 places to put some 3.5-inch spinning hard drives or some 2.5-inch SSDs, probably the same size so they can mirror each other, and this will create either a RAID 0 or a RAID 1 configuration. A RAID 0, this is the last time I'm going to mention it because it's not recommended. RAID 0 just means if I have 2 of these 8 terabyte hard drives, well, I have 16 terabytes available, and if one goes bad, I lose everything. That's awful. That's kind of the opposite of what we're trying to do. A RAID 1, on the other hand, is a little bit nicer solution. This is also known as a mirror. So in my example of my 2 8 terabyte hard drives, if I lose one, there is a copy or a mirror of it available in the other drive. So all I would have to do is replace it with another 8 terabyte or potentially larger hard drive, and it would then rebuild itself and my array would be accessible again. But that entire time, as long as the other drive didn't die while trying to recover, I would have all of my data, no problem. If you're someone that has a lot more data and you need to have it in even larger capacities or the ability to scale that data, you might be looking for something like a 4 or a 6-bay setup. This is pretty common with creatives that have thousands upon thousands of photos or video files. And this allows you some more complex RAID backup strategies. So not just a RAID 1 or a mirror, you can gain access to RAID 5 or RAID 6. The ones I'm going to be talking about today mostly are RAID 5 because they make the most sense for kind of the casual home user. A RAID 5 allows us to stripe our data across multiple disks. So for example, if I have now 4 of these 8 terabyte hard drives, in a RAID 5 configuration, I allow myself to have 32 terabytes of raw storage, but usable storage, it's closer to 24. And usually there's some overhead. It's going to be a little bit less than, it's going to be about 20 terabytes of usable data across those drives. I lose some capacity, but I gain the resiliency of I can lose one drive, and then as long as I don't lose 2 or more, I'll be okay. And then we have the solutions for our data hoarders. If you need 8 or more bays of storage, yeah, you might be a data hoarder. I'm one of them. When I built my first home NAS, I wanted the ability to grow into 8 or more drives in there. And at the time, there was just a lot of expensive solutions out there, and I really felt like I could do better. For more about data resiliency and server configuration, I'm going to put a link in the description below to a great resource called raidisnotabackup.com. Yes, I know, I just said RAID and I talked about backups, but a RAID in and of itself is not a backup. Check out more in the description below. If you're someone that has multiple PCs, multiple phones, multiple external hard drives, and you want to centralize that data and create copies of that can be accessed by those multiple devices, you probably need a NAS. A NAS doesn't have to be anything fancy. In fact, if you're the DIY type, you can probably make one from some computer components you have lying around. An old PC, an old laptop. I've even seen folks make them from phones. That's a little bit more advanced and way beyond the scope of this video, but it's able to be done. Back in 2020, when I was looking for a NAS solution, if I wanted 8+ bays of storage, the ability to expand my RAM, and access from multiple computers quickly, I was going to be spending $2,000 to $3,000 before adding hard drives, and that was just way out of my budget. So I rolled up my sleeves and started looking at cheap solutions, new and used. I ended up with this tiny little cube computer made from an AMD Ryzen 3200G CPU, or APU at the time, 16 gigabytes of DDR4 RAM, and a whole bunch of bays ready to accept some 8 terabyte hard drives that I ended up picking up. All said and done, I was in for less than $1,200, so a third of what it would have cost me with hard drives. The only real downside I can think of to doing it yourself is that when something breaks or goes wrong, you're the one stuck fixing it yourself. And in the last 5 years of my DIY NAS being functional, I've had to replace some stuff. There was one point about 3 years ago where the power supply that was in the unit caught fire. Like a flame literally shot out of the back of the PSU. I pulled it from the wall, doused the power supply, removed every component from the NAS, and there was even like a small char mark on one of the SSDs that was running the NAS. It was terrifying. I was like, oh my God, I just lost everything. Turns out I didn't. I just had to replace the power supply, clean off the soot, get rid of the magical smoke smell coming out of everything, and yeah, my data was fine. A few cables later, we're good. That's probably not something that the average user wants to put up with. And I was willing to put up with it because I saved $2,000 by doing it myself. And lesson learned, I bought a better power supply the next time. If you're not the type that wants to struggle through all of the DIY and FIY issues, there's a lot of great off-the-shelf options now. Here in 2025, some reputable brands that come to mind are ASUS Store, TerraMaster, QNAP, Synology, and the sponsor of today's video, UGREEN. I've been excited about my DIY NAS solution, and I've wanted to talk about storage for years. So when UGREEN reached out with an offer to test out one of their new NAS units, I jumped on it because I thought it would honestly be a great fit. This handy little unit that UGREEN sent over is one of their new NAS solutions, the DH4300 Plus. It's a 4-bay NAS capable of up to 120 terabytes of storage. That's 430 terabyte HDDs. The I/O isn't too bad on this thing either. It's got a USB-A and USB-C inputs for downloading external drives, and it even has an HDMI output when you set it up as a media server. It features an 8-core ARM-based processor with 8 gigabytes of LPDDR4 RAM. The Ethernet on there is 2.5 gigabit, which allows for slightly faster upload and download speeds to your local network than maybe your computer even has installed. Overall, a really respectable set of specs compared to every other entry-level NAS. This might be the easiest to set up NAS I've ever come across. All I had to do was plug in the Ethernet cord that was supplied, plug in the 12-volt power supply that comes with the unit, mount my hard drives with the provided screws, unfortunately this one isn't toolless, and then press the power button. Once the unit gave a long beep, about a minute or two later, I had to open up a browser and head to find.ugnas.com to complete setup. If you want to connect to it manually from there, you can do that, or this thing even has NFC on the front, or near field communication. You just hold your phone that's NFC enabled right up to it, and it finds it and connects. From there, you create a user account, create your shares, and you're off to the races with your NAS. Also, the entire time I've been recording this video, the NAS has been literally 6 inches away from the microphone. So if you've heard anything, maybe like a clicking, that might have been one of the hard drives, but that's it. This thing is pretty darn quiet. What you're really getting in a NAS for this price is the easy user experience compared to some of the DIY level systems out there. I ended up going with TrueNAS, which is a free and open source Linux-based operating system, but no joke, it took me 2+ years to not be terrified of the extra features in my TrueNAS server. And I'm lucky if I'm using 20% of its total capability at any given time. Compare that to the hold your hand experience of the UGREEN NAS, and it's just a different beast. Another popular option out there is UnRAID, which has personal use licenses ranging from $50 to $250. Both of these operating systems have a host of unique advantages, with one big caveat that they all have a larger learning curve than the off-the-shelf models. Compared to some other NAS brands out there, UGREEN doesn't limit you to what type of hard drives you put in there. There's a large list of compatible drives, and you can head over to UGREEN and check the description below for a link to that. Once I have the storage connected to my home network, accessing my files is as easy as setting up a file share that my devices can see, aka an SMB file share. Then adding that address as a network location to my computer. On my Windows PC, I can just right-click in my Windows Explorer and add a network location. I even did it right from the wizard, where it just found it right away on my home network. Pretty simple. Back to that 2.5 gigabit Ethernet connection. I can drag and drop files, and it's much, much faster than if I was trying to upload them to the cloud. Out here in the sticks, I only have a 100 megabit internet connection, and uploads can be incredibly slow. When I take a copy of one of my old 3 gigabyte YouTube videos, it's going to take me well over an hour to transfer that thing. Compare that to the UGREEN NAS, which is done in less than a minute. Now, the Ethernet connection I'm using is a 1 gigabit Ethernet, but if you have a 2.5 or faster gigabit connection, you can 2.5x that speed, just shy of 300 megabytes per second. That's a great transfer rate over the network and capable of hosting multiple wireless or wired devices for simultaneous streaming. For most photographers working with simple photo and video files, this UGREEN NAS is going to have plenty of connection and plenty of overhead. If you're someone that's editing much larger video files and potentially higher video bit rates, I might suggest looking into the more professional, expandable UGREEN NAS solutions, their DXP, specifically the DXP 4800 Plus and the DXP 6800. These are 4 and 6 bay NAS solutions that allow expansion of memory and have up to 10 gigabit connections or 1 gigabyte per second upload-download speeds. Much, much nicer for that. Once I had UG NAS set up on my phone, it was as easy as allowing the UG NAS to see the pictures on my phone, and it synced my entire photo library. It even has an AI smart assistant if you want to do facial recognition or geotagging. It just creates a map based on where all of your photos are from. It's pretty cool. Prior to shooting this review video, I've had this UG NAS for just about a month, and in that time, it's been excellent. No hiccups, no unexpected slowdowns on it, and it just sits there, hums a little bit, and works. So while this thing does cost a little bit of money for you to host it yourself and run it year after year, the NAS has a higher upfront with a better return over time versus using cloud, which only goes up and up and up over time. Let me give you some hard numbers. This NAS has an MSRP of $429 USD, a little bit less if you click the link in the description below. I think it's currently at $364.99. It might even be less. So we've got the upfront cost of the NAS itself. We have the cost of the drives. 4 of these 4 terabyte WD RAID drives is $849.99 times 4, so we have $340 there. Add that to the cost of power. Now, power is a little bit tricky because the rates fluctuate everywhere, but I tracked the idle power consumption of this using my Home Assistant server, which is hosted on my UGREEN NAS, at around 22 watts. So 22 watts, even with the most aggressive EU pricing, comes out to about 65 USD per year. All in all, the overall cost for this NAS is over $750 for the first year, and then about $60 a year each year after that. And then you only have to add cost to it if you replace the drives or increase the capacity thereof. So with a home-based NAS, you're kind of buying your full capacity up front versus cloud storage. Now, cloud storage is appealing because it doesn't start as a whole lot of cost. You only pay for what you need, but you're always paying that rental fee because you're renting somebody else's computer space, somewhere else at a server farm, maybe in another country, who knows. The cost for that can also depend on how quickly you need that data, and if you need to pay to pull it back from that cloud service. Using some common cloud services like Amazon S3 Deep Glacier, having the equivalent 12 terabytes of capacity that my current UGREEN NAS array does would cost $200 a year to host. Now that's for business class access, and most of us don't need that. So $200 is a little bit of a lofty cost. Now you could use a Backblaze personal account, which would only cost $99 a year. This is unlimited storage until you need large amounts of that data back, in which case it'll be very slow and they will charge you egress fees. Basically, hey, you want your stuff, you got to pay us some money. And then we also have the more professional Backblaze B2 Cloud, which is available if you are trying to back up your own NAS units to the cloud. This also gets kind of expensive at $6 per terabyte per month, meaning to host just as much as this UGREEN NAS can costs $864 a year. The longer you own and operate your NAS, the more inexpensive it's going to become, and you can scale it out as you go, versus cloud storage, which always has a fixed cost that typically goes up as your capacity goes up. And worst case scenario, when you have NAS hardware, you do have recoverable costs. You could sell the hard drives, you could sell the NAS. With cloud, well, it's in thin air. You don't have anything to recover. So to wrap things up, managing and prepping your data for future use or future generations isn't as simple as just having a stack of hard drives laying around. Sure, you can do that, but it's disorganized, hard drives can go bad, and it's just a good idea to have extra copies of your data in the event that happens. Thanks again for stopping by. I know this was a bit of a change of pace from a film photography YouTube channel, but that's just how important I consider having copies of your data is. You don't want to lose this stuff. In the 10 plus years of working photo retail, I saw way too many horror stories of memory cards, hard drives, and whole computer systems just going corrupt. And I don't want to see that happen to anybody. It's awful. It's that total gut punch when you lose something that you know you shouldn't have. Let's keep our photographic and video memories far into the future. And if you have any questions about this UGREEN NAS or really anything network attached storage, let me know down below in the comments. I want to start a conversation about this. Was today's video helpful to you? Do you already know this stuff? Is there anything you want to add in about network attached storage? Because I think more photographers need to use it and need to know about it. Anyway, we'll be getting back to film on the channel soon, and I hope to see you in the next video. Bye-bye now. Oh, Zill, are you joining me? Are you joining me today? You joining us? Hello. Yes, we're recording. Yeah, hi. Okay, bye, boo. Bye, Zill. You gonna do it? Oh, she's joining us, the lady. Everyone, this is Zill, the Hundi. Yeah, Greyhound. Oh, pretty girl. Hello. Okay.